Hi everyone, I hope you had a wonderful weekend and are ready to kick off our fourth week of learning from home. I'm here to get us started with our math lesson for this week. We are going to be wrapping up chapter 12, and then next week we'll be going back into chapter 10 to finish up what we left undone in that chapter. So for today, right now, we have lesson 12.9 to look at. So if you would grab your math book and open up to page 747, and we'll go ahead and get started. Today's lesson is going to involve some past skills that we have worked on, not just looking at shapes, but also looking at fractional parts of shapes. So we're going to be doing some division and dividing shapes into a certain number of parts, and looking at the fraction of the shape that we divided up. We're also going to look at the area of different shapes. I know we skipped chapter 11, which talked about area, but I'll walk you through it and explain how to find the area of a shape. The first part of lesson 9 wants us to investigate a hexagon. It says to trace a hexagon pattern block. Well, I don't have pattern blocks, and I'm sure you don't either. So just do your best to draw a hexagon off to the side in your book. I was able to use the hexagon shape tool here on my computer. And next, they want us to divide the hexagon into two parts with an equal area. And I'm actually going to show how we could do this two different ways. So I'm going to clone my hexagon so I have two of them, because you might be looking at your hexagon and thinking that you could draw a horizontal line going across the middle, or you might be thinking, let's draw a vertical line going straight down the middle. So either way would be correct because it's dividing your shape into two equal parts, like part B told us to do. So now, though, when we look at each shape that we have just created within our hexagon, we need to write the new name for that shape. So when I look at the first hexagon that I split up, I have four sides. Okay, and I'm just going to trace over in red one of the new shapes that I created. And that shape has four sides, so it would be a quadrilateral. But more specifically, because it has one set of parallel sides, the top and bottom, this would be a trapezoid. So I'm going to type here trapezoid. However, when you look at the second way we could have split our hexagon, and if you drew a vertical line straight down the middle, you're going to find that you actually created a different type of shape. This shape has five sides to it, and so we call a five-sided shape a pentagon. So it depends on how you decided to split your hexagon. You would have ended up with either two trapezoids inside or two pentagons. Letter D wants us to write the fraction that names each part of the whole that we divided. So each part of our shape would represent what fraction of the whole thing. So I'm just going to scribble in this part of my hexagon. When I split my hexagon into two trapezoids, each part is representing one out of two total parts, or we would read that fraction as 1/2. Same thing if we made two pentagons within our hexagon, we would still have each part representing 1/2, one out of two total parts. Then it wants us to write the fraction that names the whole area. So basically, if we have 1/2 of our hexagon red and the other half of our hexagon blue, 2/2 is what make up the whole shape. So our whole fraction is simply 2/2. Remember, we learned that anytime our numerator and denominator are the same, it equals 1/2. And the same would be true if I scribbled in the other half of this hexagon where we made two pentagons. If I said half, a little out of the lines. If I said half of the hexagon is purple and half of it is green, I still have 2 halves to create the whole shape. So we're going to look at a lot of different fractions within our shapes today. Now, number 1 down below wants us to explain how you know the 2 shapes have the same area. So how do we know the purple pentagon and the green pentagon are the same? How they have the same area? And remember, area is the amount of space within the shape. Well, both pentagons are the exact same shape and same size. So that means the area, the amount of space those 2 pentagons take up, would be exactly the same. Okay? So the shapes are the same size and shape. I need to make my writing a little bit smaller here. So because the shapes are the same size and shape, they take up the same area. So they cover the same area. Okay? And if we had pattern blocks, we would be exploring with using pattern blocks, and we would be putting pattern blocks on each part of the hexagon that we divided it into, and we would see that the areas are exactly the same. On number 2, it says to predict what would happen if you divide the hexagon into 3 shapes with equal area. What fraction names the area of each part of the divided hexagon, and then what fraction names the whole area. So they want us to take our hexagon and now split it into 3 parts. So to do that, this is a little trickier to split it into 3 parts. Luckily, I have a special tool that helps me kind of make straight lines. It's actually kind of neat when we do that because it almost looks like I created a 3-dimensional cube. But now my hexagon is divided into 3 equal parts, and we want to write a fraction that names the area of each part. Well, I thought it would let me divide it into 3 different colors, but apparently not. Okay, so anyways, the fraction that names each part, well, since I divided it into 3 different parts, each part is representing 1/3 of the whole shape. 1/3, 1/3, 1/3. So each part is 1/3. Okay, and then it says what fraction names the whole area. The whole area would be 3/3, because if we have 1/3 plus 1/3 plus 1/3, 3/3 would be our total. And if you look at what shapes we created, all 3 of these shapes inside of the hexagon have 4 sides to them. And notice each side is equal and opposite sides are parallel. So we created a quadrilateral, but more specifically, we created a rhombus inside. So that was just a little extra as to what shape we created. Okay. On number 3, to think smarter, show how you can divide the hexagon into 4 shapes with an equal area, and each part is what fraction of the whole shape. So if we wanted to take our hexagon, and they have one drawn for us, and split it into 4 parts, I'm going to make a vertical line and then a horizontal line. And you can see each of the 4 shapes we created are the same. But what fraction is each shape? Well, each fraction would be 1 out of 4 total, or the fraction 1/4. Okay? Over to the next page, making connections. It says the rectangle at the right is divided into 4 parts with equal area. Write the unit fraction that names each part of the divided whole. So we're looking at this rectangle, and I'm just going to trace the outline of the rectangle just so that we can see the actual shape we're talking about here, the outer part of it. So we're looking at this rectangle that I'm tracing in blue, and within the rectangle you can see how they divided it into 4 different parts. We have like a light green area, a blue, kind of like a yellowish, and a purple. So we need to think of a unit fraction that names each part of the divided whole. Remember, a unit fraction always has 1 as your numerator. So how many parts is in our rectangle? Well, we said there were 4. So each part is representing 1/4 of the whole rectangle. What is the area of each part? Area, again, is the amount of space the shape takes up. So to figure out the area, we simply count all of the squares within one of the shapes. And there's a total of 5. And you can count any of them, count any of the shapes within the rectangle, and there would be 5. And we do have to label this as square units. And I'm abbreviating square. Now, if we knew that this was drawn out using inches or centimeters, then we would say square inches or square centimeters. But we don't know what the units measurements are, so we just say square units because we counted 5 squares inside of one of our shapes. How many 1/4 parts does it take to make the whole? Well, because the whole rectangle was split into 4 smaller shapes, it's going to take 4 total parts in order to make the whole rectangle complete. It's kind of like piecing puzzles together. Is the shape of each of the 1/4 parts the same? So when we look at the green shape, the purple, the blue, and the yellow, are they all exactly the same? No, they do not all look the same. However, they do have the same area. Each one is 5 square units. 3, 4, 5, and 1, 2, 3, 4, 5. So that takes us to the next question. Is the area of each of the 1/4 parts the same? And we're going to say yes. And we have to explain why. And we're going to say because each shape covers 5 square units. Okay, so even though the shapes don't look the same, okay, they still cover the same area of 5 square units. All right, let's keep going here. Moving along, we now need to divide the shape into equal parts. Draw lines to divide the rectangle below into 6 parts with an equal area. So we want 6 parts to this shape, and we need to figure out how to split it. You know, this can be kind of challenging to figure out how to divide this big rectangle into 6 parts that are equal. So one trick I always follow is first I count the area within the rectangle, and then if there's 6 total parts, I'm going to take the area and divide it by 6, and that's going to tell me how many total parts need to be in each of my 6 shapes, what the area of each shape needs to be. So if you look here, there's 1, 2, 3 squares going down, and then 1, 2, 3, 4, 5, 6, 7, 8 going across. So a quick way to find the area is to do length times width. So there's 3 from my width and 8 across from my length, and 8 times 3 is 24. So the total area of the rectangle is 24. If I divide that by the 6 shapes that I need to make within that shape, 24 divided by 6 equals 4. So that means I need to, when I split this rectangle into 6 parts, I need to have an area of 4 within each of my new shapes. So if I go like this, this creates a shape and it has an area of 1, 2, 3, 4. And then I can do a little square here and it has 1, 2, 3, 4. That's 2 shapes. I need to make 6. So I'm going to go do a long piece of 4. 1, 2, 3, 4. I'm just checking my work as I go. I can make another square that has an area of 4. So now I have 4 shapes. I need to make 6. If I split like this, 1, 2, 3, 4, and then the last one here, 1, 2, 3, 4. Okay, so if that makes sense to you guys, you'll see that I took my big rectangle and I split it into 6 parts. And each part has an area of 4 square units. In order to better help me divide this on the first try, I took the total area of my rectangle, which was 24, and divided it by 6 because we needed 6 parts in our shape, and it equaled 4. So each shape, each part needed to have an area of 4 because we needed an equal area. So to answer some of the questions about what we just did, write the fraction that names each part of the divided whole. Well, since we made 6 total shapes out of our rectangle, each shape that we made would be 1/6 of the whole rectangle. Write the area of each part. Well, each part we created has an area of 4 square units. And I kind of counted them as I went along to make sure that the area was equal in each of the new shapes that I was creating. And then each part is blank of the whole shape's area. Each part is going to represent the same unit fraction, 1/6 of the whole shape's area, because each shape that I created in my rectangle is 1 out of 6 pieces to complete the whole thing. So I know fractions and area can be kind of tricky, but I think you'll get the hang of it as we continue on. So down to the share and show, it says to divide the trapezoid into 3 parts with an equal area. Write the names of the new shapes. Then write the fraction that names the area of each part of the whole. So looking at this trapezoid here, we need to split it into 3 parts. We have to be careful when doing this. I see 3 triangles that I can create out of this trapezoid. So each part of the trapezoid that I just made is now a triangle shape because it has 3 sides, 3 angles. So that would be the name of the new shape that we created. And then we need to write a fraction for what each part represents. Each triangle is representing 1/3 of the whole entire trapezoid because there are 3 triangles and they would each represent 1/3 of the whole shape. Okay? If you feel like you need to take a break, feel free to pause the video and come back. Otherwise, hang out with me for a little bit longer. We're almost halfway through the lesson. And as we get the hang of this, this should go a little smoother. Over here on the next page, we need to draw lines to divide the shape into equal parts that show the fraction given. So they give us a hexagon here, and they want us to split the hexagon into 6 pieces because the denominator on the fraction is 6. So in order to do that, I'm going to first draw a vertical line straight down, and then if I go straight across horizontally, that's only going to give me 4 parts. So I then need to do 2 diagonal lines from vertice to vertice, corner to corner. And now you can see that my hexagon is split into a total of 6 equal parts. And each of those parts have the same area. They're the same size, same shape, so they take up the same amount of space. And each one of those shapes actually are the same shape, being that they are all triangles. All right, number 3, they want us to take our quadrilateral here, or a parallelogram, and divide it in half. So that means we want to have 2 parts that are equal. So I'm going to draw a diagonal line to create 2 of the same shapes within this quadrilateral, and those 2 new shapes have the same area, and they are both triangles. On number 4, we need to split our rectangle into 8 total pieces that have the same area. So I'm going to first draw a horizontal line that splits my rectangle in half, so I have 2 pieces. I'm going to draw a vertical line straight down. Now I have 4 pieces, and then I'm going to split each of those down the middle, and this should give me a total of 8. So now I have 8 smaller shapes within my rectangle that each have the same area. Moving along, number 5, 6, and 7, they want us to draw lines to divide the shape into equal parts that have the same area, and then to write the area of each part as a unit fraction. So we are doing just what we did up top, only they're not giving us the unit fraction. We have to write that ourselves. So on number 5, we need 8 equal parts. So that means we need to take this square and split it into 8 equal shapes. Now, first I want to figure out the area of the square. So there's 4, 8, 12, 16 total squares within our shape. And if I need to divide that into 8 parts, 16 divided by 8 equals 2. So that helps me out when I'm creating new shapes, because each one I know needs to have an area of 2. And I'm just kind of tracing the outside, and then I'm going to split. And there we go. I've got 8 equal parts, and each part is representing 1/8 of the whole shape, 1 out of 8 pieces. Okay, on number 6, we need to make 6 equal parts. Again, just looking at this rectangle, it's not very clear to me how to divide this into 6 equal parts. So if I count the area and figure out the total square units, then I can divide that by the 6 shapes we need to make. So I'm going to count by 3s going down each column. 3, 6, 9, 12, 15, 18, 21, 24, and 24 divided by 6 equals 4. So each shape I make has to have an area of 4. Okay, let's see here. I can draw this here. So I've got 4, 4, 4, and that's 3 shapes. There's another 4. Okay, so if you look, I've got 1, 2, 3, 4, 5, 6 different shapes that all have an area of 4 square units. So each of those shapes would represent 1/6 of the whole rectangle that we started with. On number 7, we need to take this odd shape and divide it into 4 equal parts. And if we count the total area that we're working with, we can divide that area by 4 to see the area of what each shape has to have. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's a total of 12 square units divided by the 4 equal parts we need to make. 12 divided by 4 equals 3. So each of the new shapes we make needs to have an area of 3. There's 3, and I'll draw a line there. Okay, so now there's 1, 2, 3, 4 shapes, and they each have the same area of 3. And so each shape would represent 1/4 of the total shape that we started with. All right, let's go down to the problem solving here. It says to use reasoning. If the area of 3 quadrilaterals is equal to the area of 1 hexagon, so it takes 3 of the blue shapes to make 1 of the yellow, the area of how many blue shapes would equal 4 yellow hexagons. So it took 3 blue to equal 1 yellow, and now we have 4 yellow. So that simply means we're going to take 4 of the yellow hexagons, and we would want to multiply that by 3 because it takes 3 blue rhombuses to equal 1 hexagon. So if we have 4 hexagons, times it by 3 rhombuses to make each one. 4 times 3 equals 12. So we would need 12 blue rhombuses in order to make 4 hexagons. So a little bit of multiplication there can help us out even though we don't have the actual shapes to play around with in front of us. For number 9, think smarter. It says to divide each shape into the number of equal parts shown. Then write the fraction that describes each part of the whole. So we've been doing this. Let's go ahead and divide our hexagon into 2 equal parts. And there's 2 different ways you can do it. But I'm going to simply just draw as straight of a line as I can down the middle vertically. And since I only had to make 2 equal parts, my fraction is going to be 1/2, or 1/2, because each part is 1/2 of the whole. Okay, the next shape is an octagon. It has 8 sides, but we want to split it into 4 equal parts. And so I'm going to draw a horizontal and a vertical line and have 1, 2, 3, 4 parts. And so my fraction would be 1/4. Each of those parts inside is now 1/4 of the whole. And then the rectangle we want to split into 6 equal parts. So I'm going to just draw a horizontal line first, and then 2 vertical lines going down. And that gives me 1, 2, 3, 4, 5, 6 parts. And so the unit fraction here would be 1/6. Each part is 1 out of 6 total. Hopefully you're catching on now, getting the hang of shapes and fractions and how it's related. For this next one, number 10, it's a sense or nonsense question. I'm going to play our math on the spot video, and it does match up to the question in the book. So please follow along with the video and complete this question in your book as you go along. Okay, you're going to be looking at this hexagon and the trapezoid and seeing how the area of the different shapes you create match up. So let me get the video going here and follow along in your book, and make sure you are recording your information as you see in the video. Maybe here, where'd we go? All right, here we go.
And so we've got that.
Rewind. I don't know how that happened. Technology is driving me.
You know, one of my favorite ways of learning math is by making mistakes and seeing if we can actually learn something from that experience and try to build an insight. Let's take a look at an example and see if someone's work offers us that same opportunity to grow and think. Let's check it out together. So, Alexis said that the area of 1/3 of this trapezoid is greater than the area of 1/6 of the hexagon because 1/3 is greater than 1/6. The question is, well, what do we think about her statement? And if we don't like it, maybe can we even offer an alternative? So let's think about this together. First of all, if you look at these two shapes, so here's a trapezoid. Remember, trapezoid is just a four-sided figure where exactly two sides are going to be parallel. These sides aren't. And so we've got that figure, that figure, that figure, that one, and this figure. And this is a hexagon, which, as you can see, has 6 sides. And if I bring it over here, notice one thing, by the way. We want to take a look at 1/3 of the trapezoid and compare it to 1/6 of the hexagon. Well, check it out. First of all, notice if I just drag this over, look how they perfectly align. So these two shapes really have something in common because they line up perfectly. In some sense, if you notice, the trapezoid represents half of the hexagon here. That's kind of interesting, isn't it? But let's take a look at what we're supposed to look at. 1/3 the area of the trapezoid. Well, 1/3 of the area of the trapezoid is I take the trapezoid and I cut it into 3 equal pieces, which has already been done for us. You see, there's this right side up triangle, and this upside down triangle, and they're all the same exact size. And so any one of those is 1/3. And the way to think about that is to actually think about the fraction as being made in the following way. Let me just raise this up so you can, I really want you to see this. So here's a way of thinking about it. We can actually create a fraction. And what we do is we take the number of shaded parts. And by the way, let me actually now shade that in for you. So I'm going to shade in 1/3 of it. And I'm not very good at shading. Are you good at shading? Maybe you're better at shading than I am. I'm not that great, actually. I'm shading, I'm singing my shading song. I'm shading, come along. There we go. Now, what do I see? Well, what I see is the number of shaded parts here is just 1. And I divide that by the total number of equal parts, which is 1, 2, 3. And that's how I know I've shaded 1/3. I've shaded 1/3 because I have 1 of 3 equal parts. Now, with respect to the hexagon, I'm supposed to actually shade in, look at the area of 1/6. That means I divide it into 6 equal parts. So the idea here is to create a fraction where the number of parts, so I'm going to shade it right now. So I'm going to do some more shading. I'm doing more shading, because I'm supposed to shade this piece. It is 1/6 because it's 1 of 6 equal parts, and I am done. Okay, so what happened here? Well, here I see number of shaded parts is 1 out of 1, 2, 3, 4, 5, 6 equal parts, and that's how I get the fraction 1/6. Now, if you look at this, you see 1/3 greater than 1/6, but it's 1/3 of what is greater than 1/6 of what? Well, 1/3 of the trapezoid, you can just see visually, in fact, is actually the exact same size as 1/6 of the hexagon. You can just see that, because remember when I dragged that over, they matched up perfectly? So these are actually the exact same shape, exact same size. So actually, I think Alexis made a really good mistake, because while it seems like this fraction 1/3 is greater than 1/6, it really is 1/3 of what compared to 1/6 of what. So without that, these guys really are not comparable, because it's hard to say. So I'd say that, in fact, this is probably not exactly perfect. And in fact, we can say that 1/3 of this trapezoid, which is this, is actually going to be equal to 1/6 of this. And then to be very, very precise, 1/3 of this, the area of the trapezoid, so exactly that red region, is exactly the same size as the area of the red region here. So here's what we might say. We could say the two fractions cannot be compared, because it's got to be 1/3 of something compared to 1/6 of the same something. So that's no good. But here's what we can do. We can, in fact, compare the two fractional areas. The two fractional areas can be compared. So we can say that these areas are equal. So 1/3 the area of the trapezoid is equal to 1/6 the area of the hexagon. That is something that we can say. But notice how it's important that we say 1/3 of what compared to 1/6 of what. It's very, very important. In this case, when we look at 1/3 of the area here compared to 1/6 the area here, independent of 1/3 and 1/6, we see that those values, in fact, are equal. So that's very exciting. It's very exciting when we see things are equal. It's also very exciting when we just understand math that much better. So enjoy looking at various fractional parts of other pieces of area. Have fun looking at math, and I'll see you soon.
All right, guys, so hopefully you followed along in that video. I know this was kind of tricky because it did not make sense what Alexis was first trying to say, but we could then start to make a little bit more sense out of it when we were a little more specific with our answer. So you had to first divide this hexagon into 6 equal parts. So I'm just going to do that real quick in case you didn't do that along with the video. And then the trapezoid, we needed to split into 3 equal parts, something like that. And which pattern block represents 1/6 of the whole area? Well, that's just simply asking what kind of shapes did we create inside the hexagon. And it was a triangle. Oh, forgot the T on there. And then when we divided the trapezoid into 3 parts, we also created a triangle inside of the trapezoid. And so that helps us start to see, okay, if we made triangles here and triangles on the other shape, are those the same? And Alexis, was saying that the area of 1/3 of the trapezoid is greater than an area of 1/6 of the hexagon because 1/3 is greater than 1/6. Now, it is true to say 1/3 is greater than 1/6. However, if you recall when we learned about fractions, we had to be talking about shapes that were the same size, same shape. Well, the hexagon and the trapezoid we started with were not the same shapes to begin with. They're not the same size. In fact, a hexagon is twice the amount of a trapezoid. So we cannot just compare those 2 fractions alone. We have to understand what shape those fractions are being taken from. So her statement does not make sense. And our friend in the video was kind of explaining that to us, that no, because Alexis was just looking at the fractions, not the shapes too. So she has to actually look at the shapes that she was dividing up into fractional parts, okay? And so it doesn't make sense for her to say that, because as we saw in the video, he proved to us that one triangle piece from the hexagon is actually the same as the triangle piece within the trapezoid. So to write a statement that does make sense here, he told us that we could write the area of 1/3 of what? Of the trapezoid. The area of 1/3 of the trapezoid, we have to know what shape we're talking about, is equal to the area of 1/6 of the hexagon. Okay, so when we had the hexagon split into 6 pieces, one of those 6 pieces was a triangle piece, and that 1/6 piece was the same as the 1/3 piece in our trapezoid. So I know that still might be a little bit confusing. Fractions are always very tricky and hard to understand in 3rd grade, but as long as you understand that you can't just compare those 2 fractions alone, because the shapes that we were working with were different shapes. It's not like comparing fractions of a pepperoni pizza to a fraction of a cheese pizza, and both pizzas are circular and the same size. So that, might make a little more sense. If we go deeper here, what if you divide the hexagon into 3 equal parts? So I kind of pulled the hexagon down here, and now if we divide this into 3 equal parts, which is a little harder to do, and our trapezoid, remember we had 3 equal parts. So I'm going to make our trapezoid here have 3 close to equal parts. It says, write a sentence that compares the area of each equal part of the hexagon to each equal part of the trapezoid. So now that means we're looking at one of these pieces from the trapezoid and one of these pieces from the hexagon. Now they're not the same anymore. They're not both triangles like they were up above. If you see now, the trapezoid still has a triangular piece in it. And now inside of the hexagon, we have a rhombus piece, which is bigger than the triangle piece in our trapezoid. So we're going to say now the area of 1/3 of the hexagon, 1/3 of the hexagon is greater than the area of 1/3 of the trapezoid. Okay, so now that we split the hexagon into less shapes, less pieces, so instead of having 6 pieces, now there's only 3. Each piece of the hexagon is now greater than each piece of the trapezoid. All right. Final stretch here, boys and girls, with the practice and homework lesson. So they did the first one for us, except we need to draw lines to divide that shape into equal parts. They might have done it in the book, but it's kind of hard to see on here, so I'm just going to do it again. And we needed to make 3 equal pieces, and each piece is 1/3 of the whole. On our next shape, the rectangle here, we need to make a total of 8 equal pieces since our fraction is 1/8. So I can make some vertical lines here and just drawing straight down, and what I end up with is a total of 8 equal parts. Okay, so that's how that would look. And then on the third rectangle, we need to show a unit fraction of 1/2, which means I need to find the middle, and you can do this either vertically or horizontally, but now my rectangle has 2 equal parts. 4, 5, and 6 is the same thing, except we have to write the fractions that each part represents. And on number 4, we need to take this odd shape and create 4 equal parts out of it. So first I want to count the total area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if there's 12 squares inside, and I need to divide that by 4 parts, 12 divided by 4 is 3. So now when I'm making new shapes, each new shape inside here needs to have an area of 3. And when I do that, I get 1, 2, 3, 4 equal parts. And each part would represent 1/4 of the whole shape. On number 5, we need to split this shape into 6 equal parts. And this shape has a total of 12 units, 12 squares inside, divided by 6 equals 2 each. And so I'm going to do this and then split that down the middle, and I get 1, 2, 3, 4, 5, 6 equal parts. And each part is going to represent 1/6 of the whole shape. And then on number 6, we need to split this into 3 equal parts, and I can see just using my eyes that I can do that by drawing those 2 vertical lines. I've got 1, 2, 3 equal parts, so each part is representing 1/3 of the whole shape. Number 7, problem solving. Robert divided a hexagon into 3 equal parts. Show how he might have divided the hexagon, and then write the fraction that names each part of the whole. So basically, we need to just carefully split this into 3 equal parts. You've seen me do that throughout the lesson. And now that we have 3 equal parts, we write the fraction each part represents, which is 1/3. Because there's 3 total parts, that's our denominator. And when we look at 1 part, that would be our numerator. On number 8, they wanted us to practice tracing a pattern block, dividing it into 2 equal parts, and writing a unit fraction to describe the area of each part. We don't have pattern blocks, but you might just draw a polygon shape. You could draw a square, a rectangle, a rhombus, a triangle, a hexagon, a pentagon, whatever you want to draw. I just drew a quick rectangle, I guess, and split it into 2 equal parts. And no matter what shape you split into 2 parts, your unit fraction is going to be 1/2 because you have 2 equal parts. Over to the next page, our lesson check. What fraction names each part of the divided whole? Well, since there are 3 total parts in this whole trapezoid, each part represents 1/3. And then number 2, what fraction names the whole area that was divided? Well, let's see. There's 1, 2, 3, 4, 5, 6, 7, 8 total parts. And if we want the whole thing, we would say as a fraction 8/8. All right, spiral review. Lil drew the figure below. Is the shape open or closed? Well, it looks to me like it is a closed shape, but remember, because it has curved paths, it would not be a polygon. We would call it a circle because it does have a name, but it would not be a polygon. How many line segments does this shape have? Line segments are the straight sides to the shape, and there are 5, and we call a 5-sided shape a pentagon. Okay, last couple of questions here. Where would a square be placed in the Venn diagram? So if we had a square shape, let me just give you a quick square to look at. Where would we put it? Is it a polygon with right angles? Yes, it does have right angles. Is it a polygon with all equal sides? Yeah, actually. Oops. So it technically could go on both sides, which means it would go right in the middle. Okay, whoa. Okay, so a square actually goes in the middle because it has right angles and it has all equal sides. And then number 6, where would a rectangle be placed? So let me just get a quick rectangle here for us to see. Where would we place a rectangle? Does it have right angles? Yeah. Does it have all equal sides? No. So we would keep it in the polygons with right angles. Okay? All right. So boys and girls, that ends our last lesson of chapter 12. The other part of your math assignment for this week is to do the end of the chapter review. It is 6 pages long, I believe. So we split it into 2 different parts, but you'll find that my video is just one video that has the whole lesson check at the end of chapter 12, but you can feel free to break the video up into 2 parts, or you could sit down and hang out with me the whole entire time. I'm also creating a practice quiz, which is completely optional. It is not graded, but it will be posted on my Google Classroom page under additional math resources. But it might be something fun just to do to test your knowledge of this chapter, to see how well mom and dad were your teachers during all of this, or to see how well you taught yourself, or even just to test out how well I taught through the videos if you watched them each lesson. Either way, it's just an optional activity to continue to enhance your math skills. I hope that you guys are all doing well. I really, truly do miss you, and I look forward to our conversations each day, whether through Remind, email, or especially when we hop on and do some Zoom meetings. So I will try to do some sort of video chat this week so we can get together with whoever is available. All right, guys, I've taken up enough of your time today, so enjoy the rest of your day, and I will see you tomorrow.